Hey guys, welcome to question MM296 of the Maths Methods Fortify study guide. Now this is a 3-mark question and it says part of the graph of the function f of x equals negative 2x squared plus 2x take 15 is shown here. If the shaded area is equal to 176 on 3 square units, find the value of a. Awesome. So our area from negative a to a is 176 on 3 and we're going to use that in our calculations. Alright, so first things first is, again, to recognize that the area is 176 on 3. And to find the area, or to find the shaded area under a graph, we obviously use our integration. So our integral from negative a to a, so from here to here, is equal to 176 on 3, like the question tells us, of negative 2 x squared plus 2x minus 15. Awesome. Now, before we do anything, I would probably just, there's two ways to do this. We could take the constant out here and then kind of move it to the other side. But I'm just gonna expand it for. There's no real reason why. Just the way I'm gonna do it. So we get negative 2x squared take 4x plus 30 dx, and then from here we can now integrate this, right? So negative 2x squared, we add 1 to the power and divide by the new power. So we get negative 2x cubed divided by 3 minus 4x squared over 2. So add 1 to the power, 2, divide by the new one, plus 30x from a to negative a. Awesome. Now, now we can just sub in our normal values, right? So a and negative a we can sub in. So we get negative 2 a cubed over 3 minus, now I'm going to change this to 2x squared, right, because 4 divided by 2 is 2. So 2a squared plus 30a, and that's our first bit. And then we're going to minus our second bit, which is negative 2 negative a cubed over 3 minus 4 negative a squared over 2 plus 30 negative a. Awesome. Now, what we actually end up with, I'm going to rub this bit out. What we get is, and that was 176 on 3, what we end up with is negative 4a cubed over 3 plus 60a. Cool. And then what I'm going to do is, so that's just this simplified down. Obviously you'll go through a bit more of a process, but that's essentially it. So this is actually our first mark here. And then I'm going to multiply both sides by 3, okay? So then we get 176 equals negative 4a cubed plus 180a. I'm going to move everything to one side to get 0 equals negative 4a cubed plus 180a take 176. And then from here we can simplify that down to a cubed take 45a plus 44. Awesome. Sweet. So now, because we don't have a calculator, we're going to need to do this a bit of a long way, unfortunately. So what we're going to need to do is find a factor of this polynomial so that we can then long divide it. So what we're going to do is, I'm going to say let a equal 1. Which means 0 equals 1 cubed, take 45, 1 plus 44. So 1 minus 45 is negative 44, plus 44 is 0. So 0 equals 0. That means a equals 1 can be true, which means that a take 1 is a factor. Okay? So you would have learnt this. This is the, can't even remember what it's called. It's the polynomial factor law. So if we know that a take 1 is a factor, that means that we can put this into the other formula. So actually, let me just rewrite that. So 0 equals a cubed take 45a plus 44. Now, at this moment, we could take this and do long division and do this divided by this, but I don't like doing that. I think it takes too long, so I'm going to do it my way. I call it the grouping method. I don't know if this is actually taught in schools at all, but this is just how I do it. So what we're going to do is we're going to grab this factor, a take 1, and because this is a cubic, so 3 multiplied by itself 3 times, we're going to write this factor out 3 times. Okay, so whatever the highest degree polynomial is, we're going to write it out that many times. So from here, now we actually want to fill in these spaces to multiply into the brackets to get this. Okay, so what I mean by that is we're going to put something here that multiplies by a to get a cubed. Okay, so what multiplies by a to get a cubed? A squared, right? So we get a squared times a, which is a cubed. But then we get a squared times -1, because we're basically expanding these brackets. So we get a squared times -1, which is take away a squared, right? But our only problem with that is that we don't have an a squared in here. We don't want this a squared. So we actually want to cancel that a squared out using our next spot, right? Because this a squared has to go here to get that a cubed, but we don't want this here, okay? So what do we have to put here to cancel out our negative a squared? Well, if we have negative a squared, we want to add a squared here. So what do we have to put here? Plus a, right? Because we get plus a times a, which is a squared, so plus a squared. So then our negative a squared and our positive a squared cancel out. That's exactly what we want, because we don't have an a squared in here. We want this bottom bit to equal this top bit. So then we get a times -1, which is negative a, and then we want our next bit to be negative 45a, right? So what do we have to add to negative a to get negative 45a? Well, we need to add another negative 44a, okay? So what do we have to multiply a to get negative 44a? Negative 44, right? So we get negative 44a, take away 44a. Negative 44 times -1 is positive 44, which is our answer, right? So if we rewrite this, we get a cubed, this negative a squared and a squared cancel. Negative a plus, or negative a take 44a is negative 45a plus 44, which is exactly what we had to begin with. Which means, now what we do is we actually take this factor, so we get our a take 1, and then this, and this create their own factor. Okay, so a squared plus a take 44. Does that make sense? So we've basically taken these 3, factorized that out. A take 1 is a common factor, and then we've put all of these in the same bracket. Okay, so your second mark actually came somewhere up here when we found that a take 1 was a factor. And now what we can do to solve for a is do our quadratic formula. We can already say, like, this is equal to 0, so we can already say that a is equal to 1, but we just need to make sure that that's the correct answer, right? So from here, we can use our quadratic formula to solve this bit here. So we can say that a is equal to negative b plus minus square root of b squared minus 4ac over 2a, which means that we get -1 plus minus square root of 1 squared minus 4 times 1 times negative 44 over 2 times 1. All right, cool. So from here, we basically can kind of break this down and say that a is equal to -1 plus minus square root of 177 over 2, and a equals 1, right? Because we had our a take 1, 0 equals a take 1, and a squared plus a take 44. Awesome. But a equals 1 is the only value between -5 and 3. So, -5, a, 3. Therefore, a is equal to 1. So a is equal to 1, guys. That's our third and final mark for this question. It should be kind of clear that this isn't between -5 and 3, just because this is such a big number. But that's basically how you do this. So I'll just quickly run through what we did. So we got our area, which we knew in the first place. We equated that to the area under this curve from -a to a, and then we simply evaluated that and solved for a. So guys, that's it for this question. If you have any questions, please hit me up in the comments below as always. But otherwise, thanks for watching, and I'll see you in the next video.